Welcome to Think Global. In today's video, we explore the race to Mars and who will be the first to reach the red planet. From the dawn of humankind, the stars have called to us. They have been our guides, our storytellers, and our muses. The night sky with its myriad of twinkling lights has always been a source of wonder and inspiration. We've looked up at the night sky and wondered about our place in the cosmos. Each star, a distant sun, each constellation, a story written in the heavens. The vastness of space has always made us question our significance and fueled our desire to explore. Among the celestial tapestry, one point of light has always held a particular fascination: Mars, the red planet. Its distinct fiery hue has made it stand out against the backdrop of the night sky, capturing the curiosity of astronomers and dreamers alike. Mars has captivated our imaginations for millennia. From ancient myths to modern science fiction, the red planet has been a canvas for our hopes, fears, and dreams. Its mysterious surface has been the subject of countless stories and speculations. Its crimson hue, visible to the naked eye, set it apart from the other wanderers in the night sky. This unique color, reminiscent of blood and fire, has always evoked a sense of mystery and intrigue. Ancient civilizations wove stories around it, imbuing it with the powers of gods and monsters. They saw Mars as a divine entity, a celestial being that influenced their lives and destinies. To the Egyptians it was Horus, the red god of war. They believed that Mars was a powerful deity, watching over battles and guiding warriors to victory. To the Babylonians it was Nergal, the queen of the underworld. This association with the afterlife and the unknown added to the planet's mystique and allure. The invention of the telescope in the 17th century only deepened our fascination. With this new tool, we could peer into the heavens with unprecedented clarity and detail. We could finally see Mars up close, albeit as a small, blurry disk. This tantalizing glimpse only fueled our curiosity and desire to learn more about our neighboring planet. But even through the crude lenses of early telescopes, Mars hinted at a world not unlike our own. The possibility of another Earth-like planet so close to us was both thrilling and humbling. We saw polar ice caps that waxed and waned with the seasons. These observations suggested that Mars had a dynamic climate, much like Earth. We observed dark markings that shifted and changed, suggesting vegetation or perhaps vast oceans. These features hinted at the possibility of life, sparking our imaginations and scientific inquiries. The possibility of life on Mars, however alien, took root in our collective imagination. It became a symbol of hope and a testament to the boundless curiosity and ingenuity of humankind. In 1965, the United States, with NASA's Mariner 4, achieved the first successful flyby of Mars. This historic mission provided humanity with the first close-up images of the Martian surface, revealing a barren and cratered world. The data sent back by Mariner 4 was groundbreaking. It marked the beginning of a new era in our exploration of Mars, transforming our understanding of the red planet and setting the stage for future missions. In 1971, the Soviet Union's Mars 3 lander achieved the first soft landing on Mars. However, it failed shortly after landing, sending back only a partial image before losing contact. Despite this, the mission was a significant milestone in our quest to explore Mars. In 1976, the United States, with NASA's Viking 1 and Viking 2 missions, conducted the first successful extended surface operations on Mars. These missions provided detailed images and data, revealing a complex and intriguing world. The Viking missions were groundbreaking, offering unprecedented insights into the Martian surface and atmosphere. They laid the foundation for future exploration and deepened our understanding of the red planet. In 1997, NASA's Pathfinder mission, featuring the Sojourner rover, marked the first successful rover operation on Mars. This mission demonstrated the feasibility of mobile exploration on the Martian surface. The early 2000s saw the arrival of the Spirit and Opportunity rovers, which vastly expanded our knowledge of Mars. These rovers discovered evidence of past water activity, suggesting that Mars may have once harbored conditions suitable for life. In 2012, NASA's Curiosity rover landed on Mars, equipped with advanced scientific instruments. Curiosity's findings have provided critical insights into the planet's geology and climate, furthering our understanding of Mars's potential to support life. The Perseverance rover, which landed in 2021, represents the latest chapter in Mars exploration. Its mission includes searching for signs of ancient life and collecting samples for future return to Earth. Orbiters like the Mars Reconnaissance Orbiter and MAVEN have provided invaluable data on Mars's atmosphere and surface. These missions have helped us understand the planet's climate history and its potential for habitability. The journey to Mars has been fraught with challenges, from technological hurdles to the harsh Martian environment. Yet each mission has brought us closer to unraveling the mysteries of the red planet. As we look to the future, the dream of sending humans to Mars becomes ever more tangible. With each technological advancement, we move closer to making this dream a reality. continuing our quest to explore the unknown and expand the horizons of human knowledge. The dawn of the space age in the 20th century transformed our relationship with Mars. No longer a distant object of speculation, it became a tangible target for exploration. The dream of reaching out and touching the red planet, once the stuff of science fiction, was now within our grasp. The first tentative steps towards Mars were taken by robotic emissaries. These early missions, fraught with risk and uncertainty, were testaments to human ingenuity and our unyielding desire to explore the unknown. They paved the way for the ambitious endeavors that would follow. Each successful mission and even the failures taught us valuable lessons. We learned about the challenges of interplanetary travel, the unforgiving nature of the Martian environment, and the limits of our technology. But with each hurdle overcome, our resolve to conquer the red planet only grew stronger. International collaborations played a crucial role, with agencies like NASA, ESA, and Roscosmos working together to share knowledge and resources. Key missions such as Viking, Pathfinder, and Curiosity marked significant milestones, each bringing technological advancements that pushed the boundaries of what was possible. As we look to the future, the lessons learned and the milestones achieved continue to inspire new generations of explorers and innovators. The Soviet Union, driven by the ambitions of the space race, mounted an aggressive campaign to reach Mars. This was a time when the Cold War was at its peak, and space exploration was seen as a critical frontier for demonstrating technological and ideological superiority. The Soviets were determined to outpace their American counterparts, and Mars was the ultimate prize. Their early attempts, plagued by technical difficulties and launch failures, were a testament to the harsh realities of space exploration. Rockets exploded on the launch pad, and spacecraft malfunctioned before they could even leave Earth's orbit. Each failure was a stark reminder of the unforgiving nature of space. These setbacks highlighted the immense challenges of interplanetary travel. The vast distances, the unknown conditions, and the technological limitations of the time made every mission a high-stakes gamble. The journey to Mars was fraught with peril, and each mission required meticulous planning and innovation. But the Soviets persevered, pushing the boundaries of technology and daring to dream of a Martian triumph. Engineers and scientists worked tirelessly, often under immense pressure, to overcome the obstacles that stood in their way. Their dedication and ingenuity were the driving forces behind the Soviet space program. Mars 3, launched in 1971, represented a pivotal moment in the Soviet Mars program. It was a mission that carried the hopes and dreams of an entire nation, and it was backed by years of research, development, and testing. The spacecraft was equipped with advanced instruments designed to study the Martian surface and atmosphere. This ambitious mission aimed not just to orbit Mars, but to land a probe on its surface. The goal was to gather unprecedented data about the Martian environment, which could provide invaluable insights for future missions. The scientific community eagerly awaited the results, hoping for groundbreaking discoveries. The stakes were high, and the world watched with bated breath as Mars 3 approached its destination. In mission control, the atmosphere was electric, filled with a mix of hope, anxiety, and anticipation. Every second was critical, and the tension was palpable as the spacecraft neared Mars. The lander, carrying a small rover, successfully touched down on the surface of Mars, a remarkable achievement for its time. It was a moment of triumph, a testament to human ingenuity and determination. The successful landing was a historic milestone, marking the first time a human-made object had reached the Martian surface. However, the triumph was short-lived. Just seconds after landing, the signal was lost, leaving engineers and scientists with a mystery that endures to this day. What caused the sudden loss of communication? Was it a technical failure, or something about the Martian environment that they hadn't anticipated? The abrupt end of the mission left many questions unanswered. Despite its abrupt end, the Mars 3 mission marked a significant milestone. It provided valuable lessons and data that would inform future missions, both Soviet and international. The mission's data helped scientists better understand the challenges of landing on Mars and pave the way for future exploration. It was the first time a human-made object had achieved a soft landing on Mars, proving that such a feat was possible and paving the way for future missions. The legacy of Mars 3 lives on, inspiring new generations of scientists and engineers to continue the quest for knowledge and exploration. The mission's impact is still felt today, as it laid the groundwork for the continued exploration of the Red Planet. As the Soviet Union grappled with the mysteries of Mars 3, the United States was preparing its own ambitious mission. The space race was in full swing, and NASA was determined to make its mark on the Red Planet. The stakes were high, and the pressure to succeed was immense. Viking 1, launched in 1975, was designed to be the most comprehensive exploration of Mars yet attempted. This mission was a monumental step forward in our quest to understand Mars. It represented years of meticulous planning, engineering, and scientific collaboration. Viking 1, consisting of an orbiter and a lander, carried a suite of scientific instruments designed to study the Martian atmosphere, surface, and most importantly, search for signs of life. The spacecraft was a marvel of engineering, equipped with the latest technology of the time. Each component was carefully crafted to withstand the harsh conditions of space and the Martian environment. These instruments included cameras, spectrometers, and a soil sampler, all meticulously designed to gather as much data as possible from the Martian environment. The cameras were capable of capturing high-resolution images, while the spectrometers analyzed the composition of the Martian soil and atmosphere. The world held its breath as the lander detached from the orbiter and began its descent towards the surface. This was a critical moment as the success of the mission hinged on a safe landing. Engineers and scientists watched anxiously, knowing that years of work depended on these final moments. On July 20, 1976, Viking 1 made history by becoming the first American spacecraft to successfully land on Mars. This achievement marked a significant milestone in space exploration. The successful landing was a testament to human ingenuity and perseverance. The images it beamed back, showing a desolate yet hauntingly beautiful landscape, captivated the world. These first glimpses of Mars were both awe-inspiring and humbling. The barren terrain, with its rocky outcrops and dusty plains, offered a stark contrast to the blue planet we call home. Viking 1 conducted a series of experiments, analyzing the Martian soil and atmosphere for signs of biological activity. The lander meticulously collected samples and transmitted data back to Earth. Each experiment was designed to answer fundamental questions about the red planet's potential to harbor life. The results, while inconclusive, provided valuable data that continues to shape our understanding of Mars. This mission laid the groundwork for future explorations and deepened our curiosity about the red planet. The legacy of Viking 1 endures, inspiring new generations of scientists and engineers to reach for the stars. Section 5, India's Mangalyaan, a triumph of ambition and ingenuity. India's emergence as a major player in space exploration sent a powerful message to the world. The nation's Mars orbiter mission, also known as Mangalyaan, was a testament to its growing technological prowess and its ambition to reach for the stars. What made Mangalyaan even more remarkable was its cost-effectiveness. Developed and executed on a shoestring budget, it demonstrated that ambitious space exploration didn't have to be the exclusive domain of superpowers. Mangalyaan achieved orbit around Mars in 2014, making India only the fourth nation in history to do so. The mission's success was a source of immense national pride and a testament to the power of human ingenuity. The orbiter, equipped with scientific instruments, provided valuable data on the Martian atmosphere and surface. It also captured stunning images of the red planet, further fueling our fascination with this celestial neighbor. Section 6. The race heats up. A new generation of Martian dreams. The 21st century has witnessed a resurgence in interest in Mars, fueled by ambitious plans for human exploration, and the tantalizing possibility of one day establishing a permanent human presence on the red planet. The United States, with its Artemis program, aims to return humans to the moon as a stepping stone for future missions to Mars. China, with its Tianwen program, has set its sights on becoming a major player in Martian exploration, aiming to land rovers and eventually humans on its surface. And then there's SpaceX, the private company founded by Elon Musk, with its audacious goal of colonizing Mars. SpaceX's Starship, a fully reusable spacecraft designed for interplanetary travel, represents a potential game-changer in our quest to reach the red planet. Technological advancements such as improved propulsion systems and life support technologies are making these dreams more feasible. The role of private companies like SpaceX, Blue Origin, and others cannot be overstated. Their innovations are driving down costs and accelerating timelines. Additionally, international collaborations are becoming increasingly important, with space agencies from around the world pooling resources and expertise to tackle the challenges of Martian exploration. Section 7. Challenges on the horizon, radiation, cost, and the human psyche. The journey to Mars is fraught with challenges. The red planet, with its thin atmosphere, lack of a global magnetic field, and frigid temperatures, presents a hostile environment for human exploration. One of the biggest challenges is radiation. Without Earth's protective magnetic field and atmosphere, astronauts would be exposed to high levels of cosmic rays and solar radiation. Studies show that a round-trip mission to Mars could expose astronauts to up to 700 millisieverts of radiation, significantly increasing the risk of cancer and other health issues. The cost of such an endeavor is astronomical. requiring massive investments in research, development, and infrastructure. NASA's Mars mission budget alone is estimated to be around $2.7 billion, and then there's the psychological toll of such a long and arduous journey. Astronauts would be confined within a spacecraft for months, far from home and loved ones. Studies from the International Space Station show that long-duration missions can lead to isolation, depression, and anxiety. The psychological challenges of a Mars mission would be unprecedented. Section 8. A Future on Mars. Dreams of Terraforming and Interplanetary Living. Despite the challenges, the dream of one day living on Mars continues to inspire scientists, engineers, and dreamers around the world. Terraforming, the hypothetical process of transforming Mars into a more Earth-like planet, has captured the imaginations of many. Imagine a future where Mars, once a desolate and barren world, is transformed into a vibrant planet with flowing rivers, lush vegetation, and breathable air. However, achieving this vision involves overcoming significant scientific and engineering challenges. One of the primary challenges is creating a sustainable atmosphere. Mars's thin atmosphere lacks sufficient oxygen and is composed mostly of carbon dioxide. Another critical issue is the need for water sources. While there are ice deposits on Mars, extracting and utilizing this water for human consumption and agriculture is a complex task. Creating a self-sufficient human colony requires advancements in renewable energy, life support systems, and sustainable agriculture. Current technological advancements such as Mars rovers and space habitats are paving the way for future prospects in interplanetary living. Mars, with its potential for resources and its proximity to Earth, could serve as a stepping stone for further exploration and colonization of our solar system. Section 9. Who will take the prize? The future of the final frontier. The race to Mars is a marathon, not a sprint. It demands not just speed but endurance, strategy, and a vision for the future. It will require international collaboration, technological innovation, and unwavering determination. Nations and private companies alike must pool their resources and expertise. But the prize, the opportunity to explore a new world and expand the reach of humanity beyond Earth, is one worth striving for. Imagine a thriving colony on Mars, a new chapter in human history. Who will be the first to plant their flag on Martian soil? Will it be a moment of national pride, or a symbol of global unity? Will it be a nation, a private company, or perhaps a collaborative effort between multiple nations? Only time will tell. The stakes are high, and the competition is fierce. The future of space exploration is full of possibilities. From scientific discoveries to new technologies, the potential benefits are immense. Let us dare to dream big and continue to push the boundaries of what is possible, for the sake of knowledge, for the benefit of humanity, and for the sheer joy of discovery. The journey to Mars is just the beginning. Thank you for watching The Race to Mars, Who Will Be First, on Think Global. If you enjoyed this video, please subscribe to our channel for more exciting content.